Hello, my name is Dan Summerbell. I'm co-founder and Chief Solutions Officer of Carbonry. We are a spin-out from the University of Cambridge and University College London, using artificial intelligence to help decarbonise heavy industry. Throughout the festival, we've heard how climate change is having a significant and severe impact on our planet. And that impact is starting to translate to the heavy industries that are responsible for a large proportion of greenhouse gas emissions, in the form of rising fuel prices, competition for lower carbon fuels such as biofuel, and of course, carbon taxes that are starting to take effect in certain parts of the world. This has led to a great deal of interest from the industry in how it can help reduce its emissions and control its costs at the same time. And it was research at the Institute for Manufacturing, which is part of the engineering department here at Cambridge, that showed that it was possible to make a significant reduction in the greenhouse gas emissions of heavy industries such as cement, using its existing infrastructure, but optimizing the performance of those existing assets. That research, along with research into artificial intelligence conducted at University College London, was spun out into Carbonry. And we have developed a solution that can help that industry reduce its carbon footprint while controlling its costs and without the need for large capital investment. We take data from existing industrial plants. We use a machine learning process to help model that plant so we can understand how the plant can react to any set of input conditions, be that the raw material that it's processing, the fuel type that is available, or the set of controls implemented by its operators. From those inputs, we can predict the output conditions of the fuel efficiency, the quality of the raw material, and the quality of the output product. And therefore, we're able to run an artificial intelligence algorithm over that model, allowing it to play and experiment with the effects of different input conditions, particularly the control settings, and therefore understand what the optimal control solution is to any circumstance that a cement plant operator might face. The form of learning we use to do that is called reinforcement learning. It is a branch of AI that has been particularly successful in contained environments. Most famously, it's helped beat the reigning world champion at Go. And it is very well suited to an industrial environment that behaves according to predictable laws of physics, is contained. It doesn't change on a day-to-day basis in terms of the physical infrastructure of the plant. And there is a lot of data available because plants have become much more well censored in the last 10 or 20 years. And the amount of data that they're capturing is quite significant, but the industry is not necessarily exploiting that data to the fullest possible extent. The agent learns to operate the plant to the best possible condition, given the inputs, the circumstances in which it finds itself, by effectively playing the operator, running the plant for the equivalent of hundreds and hundreds of years of human time, and seeing which control settings give the best output in terms of cement quality, but also fuel cost, and particularly, of course, carbon emissions associated with that fuel. We then feed back those recommendations as part of our software product called Delta Zero Cement to a human operator. So this is helping a human operator react to the changing input conditions rather than taking full control away from the human being. And this enables the AI to do the parts of the process that computers are very good at, processing the huge volumes of data that are being generated at any given time by a cement plant, understanding the implications of that data, and then feeding it back to a human operator who can make decisions accordingly. It then frees up the human operator to deal with things like maintenance crises or staffing or any of the day-to-day tasks that human operators find themselves dealing with. So rather than replacing the human operator, it's helping them to manage the complexity of a modern cement plant. These cement plants have huge numbers of different parameters that they are both being set by either a human operator or a simple control system based on loop feedback control. And huge numbers of data points, be that temperature sensors, pressure sensors, fuel flows, raw material feeds that are going into the plant at any given set of time. And so the challenge for our AI system is to identify the control parameters that, if set to a certain set of conditions, will give the best possible outcome for that given moment in time, and then feed that back to the human operator in a way that they can implement in a feasible manner. So it can't change too often, otherwise we're simply replacing the complexity of the existing system with a new, also impossibly complex system for the human operator to deal with, but be updating sufficiently often that you can capture the benefit from being able to control that hour-to-hour or minute-to-minute variation in the performance of the existing plant. What we try to do is we try to make every day at the cement plant a good day. And it was the research that I helped perform here in Cambridge that showed that the difference in terms of the fuel combustion and the emissions from that fuel, the difference can be as great as 20% between a very good day and a typical day at the same plant, with the same quarry, the same input material that's coming in, the same equipment that's being used. And therefore, if we can help the operator find that sweet spot, those optimum conditions, we can help them hit that high level of performance, which is within the existing performance envelope of the plant. We're not asking the plant to do anything new. And that's something that our customers in industry find very reassuring. And the impact of that can be really quite significant. We can reduce the fuel costs by as much as 8% or even more, and the fuel-derived emissions by up to 20%. And the reason those two numbers are different is that the cement industry in particular uses a very wide range of fuels. They're not just burning coal and coke, but they're also co-combusting things like shredded rubbish, domestic waste, industrial waste, solvents. They're starting to use biofuels as a way of trying to control their carbon emissions. And of course, this adds yet more complexity that the human operator struggles to deal with, at least to the optimized extent that a computer can. And so we can not only reduce the energy consumed, the gigajoules per ton required to generate the cement, but of course, not all gigajoules are created equal in terms of their impact on the plant and their impact in terms of carbon emissions. So we help to optimize that as well. Now, an important point is that I've talked about the fuel-derived emissions. Of course, in the cement industry, only about 40% of the total CO2 emissions come from the fuel that's being burned. About half of the total come from the materials, 5% or so from the electricity, and 5% from the transport. And we are concentrating on that 40%, the fuel-derived emissions. And if we can reduce that by 20%, we're reducing the overall emissions of a cement plant by about 8%. And this, of course, is an industry that is 8% itself of global greenhouse gas emissions. So this is of significant global scale impact. To put that in context, reducing the cement industry's overall greenhouse gas emissions by 8% would be the equivalent of getting about halfway to completely decarbonising the UK economy. Worth noting that this is something that is possible within the existing capital equipment that exists within the industry. It doesn't require a huge upfront investment, whereas decarbonising the UK economy has been projected to require as much as a £1 trillion investment between now and 2050. So the potential impact of this in terms of greenhouse gas emissions is really quite significant. And it works. The data that you see in front of you is from a trial deployment at a plant in India. This is a plant that was burning fossil fuels alone, and yet we were still able to reduce the fuel consumption by 8.6% consistently over the course of a 4-month trial. And two key results from that. One, that resulted in a very substantial financial saving for the plant involved. And that's something that is particularly important, not least in developing countries where they have not yet started to implement carbon taxes. We can still have a really significant impact on global greenhouse gas emissions and help those countries economically at the same time. And secondly, we saved 7,000 tons of CO2 over 4 months. And to put that in context, each person listening to this talk probably generates about 10 tons a year of carbon dioxide, give or take, each year. So that's the equivalent of 700 years of human time just in one plant over a single trial using the very first version of our software. And to us, that's hugely exciting. Our mission as a company is to have impact on the gigaton scale. We've got a long way to go, but we care about each and every ton of carbon dioxide that we're able to save. And there is substantial financial value in doing that as well. You know, the carbon taxes and carbon pricing mechanisms have been very difficult to get underway, and they have been you know, controversial in many cases. But we are certainly seeing that they are starting to light a fire under industry and get them to really take emissions reduction seriously. It's helped us generate investment, and it's helped us generate momentum in the marketplace. So that is, I think, a positive note that we are starting to see the pendulum begin to swing when it comes to the impact of carbon taxes and carbon emissions on the industrial economy. The interest from the industry has been really quite substantial, to the point of being almost overwhelming. You know, it's the old joke goes that in any small company you have you know, either not nearly enough work or far too much, and we have more interest than we can service at this point in time. We are hiring frantically in order to be able to meet all the customer demand that we are finding. And of course, that's, you know, it's a problem, but it's a fantastic problem to have. We've currently got 5 pilot projects in 4 different countries. Some of those are from some really major production groups, and we're starting also to get interest from cement industry bodies. The World Cement Association in particular have been very supportive. We've just presented at one of their conferences in Dubai. And so the market and the interest is really starting to come together, which of course is fantastic news for us as a company, but also I think very telling in terms of the direction of travel for the industry as a whole. But this is just the start. I said at the beginning that we're a company that has gigaton scale ambition, and that's what this talk is about. And I hope what I've conveyed to you so far is that we've managed to put ourselves into a very exciting position with a lot of potential. But we need to turn that potential into something far grander than what we're doing at the moment if we want to realize that ambition of having gigaton scale impact. So how do we do that? Well, there are 2 lines of attack. One is that we can expand into other industries. So we are already doing research. We have UK government funding in order to see whether this same approach that we've applied successfully in the cement industry can be applied to both steel and glass. In addition, building the models that we do, they have to be useful, they have to be functional for an individual company, an individual plant. But in building that database, we are learning more about industry and about how the materials that those industries are generating are created, and we can leverage that to have greater impact going forward. So in the diagram you see on the screen right now, wave 1 is optimization, you know, helping those heavy industry do better with what they have today, aiming for sort of, you know, that 10–20% improvement Now that in and of itself isn't going to help us hit net zero, but it is carbon we can save today. And of course, carbon saved today in terms of the temperature of the planet is more valuable than carbon saved in 2050. So that is a huge part of what we're doing. But we can go beyond. Because once you have a working model of a cement plant or a steel plant or a glass furnace, you understand what the physical limits are on the efficiency of that process. And it means that you can help tailor the investment that that industry makes and make it far more effective in terms of improving the efficiency and reducing the energy consumption, reducing the carbon emissions going forward. So that's wave two, enabling the modeling and simulation of these processes in a way that helps these industries go beyond the constraint of their existing assets and doing that in the most efficient way. And then wave three is taking the understanding of the materials themselves and the creation of those materials and helping redesign either the materials or the processes to make those materials in radical new ways that is going to help us get to net zero and beyond. And if you look at the ways that artificial intelligence has been used in protein folding and how it's revolutionized that industry, I think you can begin to get an idea of the scale and the scope of the potential when it comes to the insight that having really good data and really good models of pyroprocessing and industrial processes can give to the potential for new materials. And of course, that's going to be in conjunction with all of the brilliant people, and I'm sure you've heard from some of them over the course of this festival, who are out there trying to develop new materials and new processes. And we're excited to work with those people and help them not only improve their materials, but improve their production processes and help them get to market and help them to get to the kind of scale that they need to hit in order to have global impact in the future. So we promised you gigatons. How do we get there? We can't do it in the cement industry alone. So we're going to have to expand. And as I said, we are targeting steel and glass. And we're going to have to go beyond the 10 to 20% reduction in emissions that we're able to make today. So it's an ambitious path, but it is a possible one. And that's something that we as a company look to bear in mind as we go forward. Our mission is to have gigaton scale impact. We're currently having kiloton scale impact. By the end of next year, we intend to be on track to have megaton scale impact. And by the end of the decade, we want to be hitting that gigaton level. Thank you very much for your attention.